So today we're talking about proving lines parallel. On Monday, we talked about, okay, if you've got parallel lines cut by a transversal, then you have all these special angles with special relationships. Okay, we talked about alternate, what were some of them? One of them was, here you go. One of them was corresponding, okay, corresponding angles are congruent, right? Same side interior angles have to be right. Both inside on the same side of the transversal. What's their relationship? They equal 180, okay?
Teachers, pardon the interruption. Just a quick reminder, teachers, this is evaluation.
Okay, so corresponding angles are congruent. Same side interior angles are supplementary. What else? Okay, they really don't have one called that, but yes, that is true. Yes. What? Alternate exterior angles are, they're exact same, so they're congruent. And then what about alternate interior angles? They are congruent, right? But you're right. There is a same side exterior, and they just don't list that as a theorem for some reason. I don't know why. Neither one of my books did. Okay, so what we're going to look at today is what angle relationships can be used to prove two lines intersected by a transversal or parallel. So we're going to go backwards, okay? We're going to say, okay, what has to happen in order for me to say these lines are parallel? Look at this first example here. It says suppose two lines are not parallel. Okay, we've got lines T and N. See how they're not parallel, right? S is acting as the transversal, okay? The question is, can corresponding angles still be congruent? You don't think so? Why? Any ideas?
Those four lines are parallel, and if you cut two lines,
Okay. Yeah, the lines are going in different directions, right? They're not all headed in the same direction, kind of like what both of you said. Okay, so and here's a visual of it. If I took this right here, and I put it so that it was, this is line N, and if I put it so that it was parallel to M, right? If these two lines here are parallel, we know that corresponding angles have to be congruent, right? Okay, and so if this angle right here is 120, then this angle right here has to be 120, which means this bigger angle here can't be 120, right? And so here is that T, and remember they were not parallel, this was the transversal, and so that couldn't happen, all right? So that is one way to prove that you have parallel lines is to show that corresponding angles are congruent, okay? And so our first theorem here is called the converse of the corresponding angles theorem, and it says in two lines in a transversal form corresponding angles that are congruent, then the lines are parallel, okay? So we see here 1 and 2 are corresponding. If they're congruent, then that's sufficient enough information for me to say that the lines are parallel. Here's another one. This is the converse of the alternate interior angles theorem. And basically, the same thing is going to happen. If I look at two lines cut by a transversal, and I see that the alternate interior angles are congruent, then that's sufficient enough information for me to say that the lines are parallel. All right. Today. Okay. All right, so we're going to prove this converse of the alternate interior angles theorem. Remember, every theorem has a proof. And I'm going to show it to you by using what's called a flow proof. And a flow proof, I don't know if you've ever looked at a flow chart in science or computers. We used to, when I was in computer, we used to have to do a flow chart before we programmed anything. I'm going to show you what a flow proof does. And it's just like a table, except for it's just organized in a different way. Okay? You still have statements and you have reasons, and you use arrows to point you in the direction that your proof is heading. So, for example, if I started out with my given, I put the statement in the box and I put the reason underneath. So I have angle 1 is congruent to angle 2, and my reason is given. Now, when we do this proof, the only thing really that we know for sure right now is that corresponding angles, if they're congruent, the lines are parallel. So if I can somehow work my way to show that my corresponding angles, angles 2 and 3, are congruent, then I can say the lines are parallel with the converse of the corresponding angles. You know, because that's what we're proving.
No, not the converse.
Well, the alternate interior angles theorem says if you have parallel lines, then alternate interior angles are congruent. What we're doing is we're going backwards. We're wanting to show that if the alternate interior angles are congruent, then I can say the lines are parallel. Okay? Alright, so I'm given that angle 1 and 2 are congruent. Okay? Now, I'm trying to make a connection with 2 and 3. And I know that 2 and 1 are congruent. Does 1 have a relationship with anything?
One is congruent to 3.
The vertical angles theorem. So I can say angle 1 is congruent to angle 3, and that is by the vertical angles theorem. Okay? Well, if I put these two together, 1 congruent to 2 and 1 congruent to 3, what could I say? Okay, so these two statements go together, and you can say angle 2 is congruent to angle 3, and that would be by what? Transitive. Okay? And so now, if 2 and 3 are congruent, what can I say about L and M? That they're parallel. So L is parallel to M, and that's because the corresponding angles are congruent. So you would use the corresponding angles converse, or the converse of the corresponding angles theorem. Okay? So this is a flow proof. I kind of like flow proofs when they're already done because it kind of helps me see how a proof works. I'm not real crazy about like creating my own boxes and making it myself because I'm like, okay, am I going to put a box here or what? But I like it when they're done because to me it makes the proof make a little bit more sense. Okay, so we have another. This one's a postulate. This is a postulate, and it is the converse of the same side interior angles postulate. And so basically, if I can show that these two angles add together to equal 180, then I can say that the lines are parallel. Okay, so these two angles together add up to equal 180, then I can say that I have parallel lines. Okay, and then the last one for that is the alternate exterior angles theorem. Basically the same thing. If I can show that my alternate exterior angles are congruent, then I can say that the lines are parallel. Alright, so there's 4 ways that we know of right now to prove lines parallel. And it's basically just the converse of what we learned on Monday, okay? Alright, so looking at this, it's called model now. The edges of a new sidewalk must be parallel in order to meet accessibility requirements. Concrete is poured between the straight streams. How does the inspector know that the edges of the sidewalk are parallel? Okay, so here are the edges of my sidewalk. I can't draw very straight lines, right? Okay, and this right here is the edge of one of the streets. Okay, how would the inspector know with this information that these lines are parallel? The alternate exterior angles converse, right? Because these are both 53 degrees, those are alternate exterior angles, yes? And so if your alternate exterior angles are congruent, then the edges of those sidewalks are going to be parallel to us, okay? So this is by the alternate interior angles converse. Oh, thank you, exterior. That's what I meant, I just wrote it. Okay, so alternate exterior angles converse. Okay, if those are congruent, then those sides are parallel. Okay, so then we've got another question. It says, what is the measure of angle 1? Yes. Okay, what'd you do? Linear pair, so you said 127. Okay. Alright. Right? Yep. Okay, so what should angle 2 measure in order to guarantee that the sidewalk is parallel to Main Street? 53. Okay. So this right here should be 53. Okay, so this time we're using this line right here, and this one, and then we've got, there's our transversal. Okay, and so why would it need to be 53? Okay, with the alternate, you could go with alternate interior angles converse, right? Because they're both are 53. Or you could use the same side interior because they're supplementary, right? So really either one of those would work. Okay, so measure number 1, we said was 127. And the measure of angle 2, we said was what? 53. And so that is either the alternate interior angles converse or same side interior angles converse. Either one. Alright, so we've got two more theorems. This is two parallel lines. If two lines are parallel to the same line, then they are parallel to each other. Okay, so two lines are parallel to the same line. So let's say that A and B are parallel. These are these two lines right here, okay? So those two are parallel to each other, and B and C are parallel. Then, so these two are parallel, and these two are parallel, okay? A and C are both parallel to B. So then A and C are going to be parallel to each other, right? Okay. Then A is going to be parallel to C. It's not transitive. Transitive is a series, huh? No. Neither. Transitive is a series of equality statements or congruent statements, right? We're not saying that A and C are congruent to each other. We're saying that they're parallel with each other. And the reason is because A and C are both parallel to B. I see why you think it's transitive. It's kind of like the law of syllogism too. Law of syllogism, but they use if-then statements, right? So the idea is kind of the same, but the name of it's different. Because when you say transitive, you're talking about A equals B, B equals C, A equals C. Okay? That's transitive. You can use congruence or equality. But basically this is saying A parallel to B, B parallel to C, A parallel to C. And that, if two lines are parallel to the same line, then they are parallel to each other. Okay? Do you see the difference? Why it's not transitive? Okay? And I get that all the time. In every class. You know, I get it. But it's not really transitive. But the idea is kind of like that, but it's not transitive. Okay. And we could do, let's say, if A was parallel to B, and A was parallel to C, then B and C would be parallel to each other, right? Okay? Because A and B and A and C are both parallel to B, so then they're parallel. So you can look at it in several ways. Okay, here's another one. When two lines are perpendicular to the same line, then they are parallel to each other. Okay? So in this situation, if A is perpendicular to C, okay, so this is perpendicular, create a right angle, A and C, and B is perpendicular to C, they create a right angle, right? And this theorem says that you can state that A is parallel to B. Okay? So if you've got two different lines perpendicular to the same line, then they are parallel to each other. Okay? If I were just to look at this picture, what kind of makes me think that these would be parallel, other than the fact that they're perpendicular? They're both right angles, and where are the right angles at? In the corresponding part, right? So that kind of would help you prove it if you had to prove that. Because this is going to measure 90, that's going to measure 90, and if corresponding angles are congruent, then the lines are parallel, right? But they're taking it a step further, and they're being more specific and said, okay, well, if these two lines are perpendicular, and these two lines are perpendicular, then the two that aren't, you know, the ones they're not perpendicular to are parallel to each other. Okay, this one had a name in my other book. I think it was the converse of the... Okay, when building a gate, how does Bailey know that the vertical boards V and W are parallel? Okay, so this right here is the vertical board V, and this right here is W. Okay, so we've got V and W. It says, how does Bailey know that those are parallel to each other? Yes. Okay, because they're both perpendicular to A, right? To the same line, right? And here is my A. Okay, so you could say V and W are both perpendicular to A, therefore they are parallel. Okay, good. Alright, so let's add to that a little bit. It says, what should angle 1 measure to ensure that board B is parallel to board A? Okay, so now let's look at, let me erase this one. Okay, and I'm wanting to ensure that A and B are parallel, and I could use this transversal. You could, I guess. I didn't think about that. Yeah. But it's asking for what the measure of angle 1 is, right? So W wouldn't help me with angle 1. Yeah. So what should angle 1 measure to ensure that B is parallel to board A? 145. Okay, so if it was 145, okay, then those are same side interior angles, and if they're supplementary, so that would be the same side interior angles converse would help ensure that, right? Because if those are supplementary, then those lines are going to be parallel to each other. Okay. Bailey also needs board C to be parallel to board A. So here is C, and she wants it to be parallel to A. What should angle 2 measure? Yes. A is not perpendicular to B. A is perpendicular to B.
No, I mean parallel.
Oh, okay. A is parallel to B.
You have to figure out like how we make
Okay. But it's asking me what should angle 2 measure in order for this to happen. I see what you're thinking. Yes. Okay, so you're going to do vertical angles here, right? Okay. Okay, that would be true. And then you're saying that this then would be, oops. So then this would be 35. Okay. And so then you've got alternate interior angles, is that what you're saying? Okay, that still doesn't answer the question. Yes, you could do it that way. Heather? Megan? Huh? Oh, you want to back out? Okay. It's Megan. Sorry, I'm going to call you the wrong name all the time. Yes, what do you think? Because it's asking me what measure 2 should measure. 90, right?
Board B is board A and C are both perpendicular.
A and C are both perpendicular to V, then they're parallel to each other, right? Okay. So the measure of angle 2 should be 90, right? And that would be, that would then say, okay, well, if these two are both perpendicular to V, then they're parallel to each other. Okay. We could write that down. And that, if A and C are both perpendicular to V, then A is parallel to C, and they're both perpendicular to the C. Okay? But if they had asked me for what angle 3, did they ask me about angle 3? Okay. That might come into play here in a minute. You could have used the 35 thing. Yes? But that wasn't really answering what they initially asked you to find, okay? So you could have worked your way there. That's not necessarily wrong, it just wasn't answering what the question asked. Okay, last one. Is B parallel to C? And what we did prior to this would help us prove that, yes? Because we did vertical angles here with the 145s, right? And then we determined what 3 was, right? And so, yes, the answer would be B is parallel to C, and the answer would be yes. But what would your reason be there? Because actually, since we don't know, do we know that C is parallel to anything?
Yeah,
Yeah.
goes parallel to A.
We know it's parallel to A.
We don't.
Okay, so you could have done this in a couple of ways. Because if this is 35 and C and A are parallel, then this is going to be the alternate interior angle, right? Okay. Okay, yeah, we can go with that. So, you could also do one other thing. Since A and B are parallel, right? And A and C are parallel, then B and C are going to be parallel, right? Because they're both parallel to A, right? Okay. So that would probably be the best answer, is that A and B and C are both parallel to A. Therefore, B has to be parallel to